the passenger and baggage handling systems. So the two categories actually. The apron and gate system are required to serve for the requirements of the aircraft. As you have seen, apron is the place where they park for various purposes, and then a gate system is which enables the passengers to board the aircraft. So they are related to the requirements of the aircraft, whereas the passage baggage handling systems are required to accommodate the requirements of the passengers and checking in of luggages, collection of luggages, etc. So the two categories, one is focused on the requirements of the aircraft, and the other was focused on the requirement of the passengers. Talking about the first, aprons, there are several rules and regulations given by ICAO as to what should be some of the requirements for maintaining the apron space. The apron, as we have seen already, the space, the location where aircraft park for boarding of passengers or unloading of passengers, unloading of cargo, and then also for servicing overall this maintenance and fueling, etc. For any such purpose, the region that can be used for parking the aircraft is referred to as apron. The most important parameters that decide what should be the design, the area, and the configuration of the apron is the size of the aircraft, size of the largest size aircraft that the apron has to handle. So, depending on what the designers have in mind as the largest size of the aircraft that needs to be handled, the apron areas have to be scaled accordingly, or the sizes have to be designed accordingly. So a lot of it depends on the kind of parking that aircraft are going to have. So the parking type, that is the way or the type of parking that is going to be used for the aircraft, that has a major influence on the size and the configuration of the apron. So that takes us to the various types of parking. Types of parking of aircraft adjacent to the terminal building. So the schematic shows some possible configuration. We'll just go through the whole spectra of parking positions or parking configurations which are typically followed in airports. So what we are now looking at is, with respect to the terminal building, within the apron area, what is going to be the kind of parking that is going to be followed for, or what are the types of parking that are followed for various aircraft. Typically, these are the 5 configurations which are popularly followed in airports. Angled nose out, angled nose out, parallel. I just read the names, and I guess it doesn't have to be explained a lot because it's obvious from the sketch. Angled nose in the sense the aircraft is facing the terminal building. The upper rectangle in the sketch is is representative of the or schematically shows the terminal building. Sorry. The angled nose-in means the aircraft is facing the the terminal. Angled nose-in means it's facing at an angle. Nose-in, just nose-in means it's at right angles with the terminal. The second one. Similarly, nose-out means is facing away. Angled nose-out is facing away at an angle. And obviously, the fifth one is parallel parking, which is where the aircraft is practically parallel to the terminal building. So these are the 5 configurations, and this can vary. And in a particular instance, size aircraft, and then the facility for boarding and considerations like that. Just a photograph where you can see obviously all of them follow the this particular one, all of them follow the no sin parking, that is at right angles and facing the building. And you can see the the bridge, the this one that is used for the passenger boarding, actually in all of them. So this is actually sorry, actually the no sin configuration, where the aircraft is facing the terminal and it's almost at 90 degrees, is one of the most popular configurations, most often used, which you can see across the various sizes of aircraft in airports. So many of the large aircraft and commercial service these ones make use of the no-sin configuration at the terminals, and where it can be directly connected to the terminal by loading bridges. Loading bridge is what we see here in the previous this one, as you can see here, where the terminal is connected to the aircraft by the loading bridge. So passengers can board through that. And typically they can enter by their own power because it's driving in. It's more like coming close to the airport terminal. So they can drive in, but then in many cases, when they have to retrace, when they have to be taken out, they will have to be sort of towed out by other means. And the advantage is that the space requirement is sort of minimal as compared to other this ones, and it can park very close to the building. Actually, in north south, as we'll see, you have to slightly you have to maintain a distance between the building and the aircraft, but in north in you can go as close to the building as possible. Then angled nose-in, that is at an angle, that is the parking is at an angle, where the aircraft can come again close to the building, and there is enough maneuvering room, and it's usually used for smaller aircrafts, which can be sort of easily maneuvered within the available space. So angled nose-in is preferred for smaller aircraft, whereas larger ones would be mostly following the nose-in configuration. Similarly, nose-out also has similar restrictions as related to the space, but then when they can be taken out from the apron by their own power, but then they cannot be too close. Sorry. Actually, nose out and angled nose out, they cannot be too close to the building because the exhaust may directly hit the structure, which in many cases is not considered to be ideal. So they'll have to sort of maintain a distance between the building and their aircraft. Parallel parking usually used is considered to be the easiest one from the perspective of parking in as well as moving out. But then the disadvantage obviously is that it requires a lot of space. So parallel parking, that is parking the aircraft in a position that is almost parallel to the terminal building, requires more space. So it can be used if there are not too many aircraft at a given point of time, and there is sufficient space for the parking of a given aircraft. One more advantage of this parking is that both the front and the rear doors can be used for boarding or loading of the passengers. So both can be used for passengers to get in or get out. The bridges on both sides, because they are both are at equidistant from the terminal building. So if we look at even in a given at any given instance in any airport, you probably will see more than one of these parking configurations being followed. So it all depends on the available space at that point of time, the size of the aircraft, and the facility to move it in, move it out, the maneuvering space, etc. So these are the five main popular configurations used for parking an airport parking an aircraft in the apron. Now we'll move on to some other aspects related to the uh, uh, air side, which includes taxiways and runways. I think I'll stop this for today. I have a problem with the throat. So right now I'll keep it short, but then I'll just share these two videos in the chat box. You can please go through them. Actually, they are sad pictures. Actually, I just put it for parking. You see that a lot of aircraft are parked. In fact, they are grounded in the airports because of the pandemic scenario when the whole of air traffic was blocked. Actually, these pictures or these two reports are about 2 years actually after the during the first lockdown. We know that there was some improvement after that, and subsequently a lot of flights were in operation. But right now there may be restrictions again, but it's not as bad as they were in the beginning. So these two reports, just go through at your this one at your convenience. But then they look from the parking perspective, you can see the various types of how what are the types of parking that are followed in them. Though these are actually not operational parking, they are actually grounded. So they are actually, you can see that they are parked in the runways, taxiways, wherever there is space. Because a lot of aircraft had to be accommodated within a given airport across the world. So the entire space is made use of. In fact, the entire airside is made use of for parking. So it's a sad scenario, but then you can just go through them at least to see the different some of the different configurations that we talked about. So I titled the slide as park for the wrong reason. So don't take this as the standard way of parking, because it's parked all over, actually in taxiways and in the runways, etc. But these are actually because of grounding of the aircraft because of the closure of services. I guess I'll stop here now today. If you have any questions, we can just take it up. Otherwise, we'll meet in the next class. Tomorrow is a holiday, so we'll meet on Thursday. Any questions or comments, we can just take them right now.
Sir, any updates about the exam or viva?
No, that's a good question. I'll get back to you on that. Hopefully by Thursday, I'll get back to you. I'll see if there were any. Probably I wanted to check that. Maybe I missed out something. I'll check that, or I'll check with people like Dr. Balaji, who will be more knowledgeable than me on the rules and regulations updates on that. So I'll find out and let you know. Hopefully before Thursday, I'll find out. I'll let you know in Thursday's class. Basically, you're asking about the evaluation percentage, etc. Right? I mean, Viva
Yes.
between Viva.
Sir, we have periodicals or midterm.
Midterm, yeah. Midterm is going to be, say, all that I know from the schedule is that on the 12th day of, or rather, after 12 days of lecture. So, because since, say, there is not a centralized calendar for all the departments, because we have staggered course offering this time, because Each department may have a different time because depending on when they completed their pending lab courses. So for Aero, we started on whatever 19th or so. So we all that the exam office has given is starting from your first day, the periodical one has to be on such and such day, two has to be on such and such day, etc. So if I remember, the periodical one has to be on the 12th day after we start. I'll get there. I'll just check the department calendar and we'll get an idea about when it has to be actually.
Okay, sir.
If no other questions, we'll just stop for the day. Thank you. Thanks to all of you. Bye. Ramanathan is trying to ask something. Raise the hand. Please.
Sir, I have a doubt in CD nozzle.
What happened? Yes.
Sir, now if someone is telling CD nozzle is choked, that means the mass flow rate in the nozzle has to be constant for any case nozzle. In the sense, or can we change the mass flow rate in the nozzle?
You can. I say it is like this for a given geometry. So you are talking about a given fixed geometry nozzle. I hope no other case. I move to this discussion. So I hope no other questions on the today's topic, right? So I'll just move to what Ramanathan asked. Say for a given fixed geometry nozzle, the mass flow is maximum when it is choked for a given set of initial conditions. You think of the air to be supplied from a tank. Say, for example, in the lab we have that blue tank, right? When we are supplying air from that to the supersonic nozzle, we are maintaining a pressure inside the tank, which is the P naught, which is the stagnation pressure, right? So if you have maintained a pressure of 20 bar, let's assume 20 atmosphere within that cylinder, within that tank, then for that pressure, you get maximum mass flow when the throat is choked. Now, can I get with the same nozzle a higher mass flow? Yes, I can get. But how? If I pressurize the tank more. So if I make P naught is equal to 25 instead of 20, then I can get higher pressure, higher mass flow. So what we say or what we mean by a choked nozzle is a nozzle which admits the maximum mass flow for, a condition under which the nozzle admits maximum mass flow when the for a given operating pressure, for a given inlet stagnation pressure.
Yes, sir.
It's a function of the inlet stagnation pressure. Yes.
Yes, sir. Yes, sir. So that means if by means of that, can we say that total temperature is also more? Or
yeah, total temperature also will have an impact on it because the mass flow, they say the density, etc., is linked to the temperature. But I'm saying from practical perspective, it's more because of the stagnation pressure. Yes, strictly speaking, for a set of initial conditions which include stagnation pressure and stagnation temperature.
yes, sir. Yes. Thank you, sir.
Yeah.
Sir, I have one doubt, sir.
Please.
So for moving normal shocks, how are the change in properties different from stationary shock?
They are different actually. Sanjay had asked me a question. I will get back to you guys on that.
Yes, sir.
Maybe
I had messaged you the same
I'll put a
problem.
section on that. We'll try to discuss how the governing equations get modified for moving shocks. Because that has to be explained along with the with more details. So I'll try to do that. I'll separately have a session on that.
Okay, sir. Thank you, sir.
Yeah.
Sir, I also have a doubt.
Yeah.
Sir, now suppose if we have a convergent nozzle and for a given set of initial conditions like P0, T0, if it is choked, like if we reach Mach 1 at the throat, I mean at the convergent mode section, so in that case also will the mass flow rate be constant by further reducing the back pressure?
Yeah, it will be the same as a CD nozzle. As far as the throat conditions are concerned, that is the choking conditions are concerned, it will be similar to a CD nozzle. Yes.
Okay, okay.
Yeah.
That's all, sir. Thank you, sir.
Okay. Thank you. So thanks to all of you. We'll stop for the day. We'll meet on Thursday. Thanks. Bye.
Thank you, sir.